How are you? I hope everybody is safe and healthy. I have missed you guys terribly, but now it's time to start learning again here for the rest of the school year. So here are my videos to help you learn, and we're going to get started learning via teleschool. So one more thing, if you can name this group and the title of this song, 1,000,000 points extra credit for you. Alright guys, hope to see you soon. Hi everyone. Well, it's been a long time since I've seen you guys. Hope everybody is staying safe and healthy. But it's now time for us to get back to school and start talking about Honors Algebra 2 and polynomials in a new and different way that we've never done before. Okay, so what I'm going to teach you today is what's called the rational zero test. We have some Math Excel for school tonight for your homework that'll be due on Tuesday. Alright, what we're going to do is figure out what the x-intercepts are of this polynomial. And guys, this is something you've never done before, so this will be brand new. It really is a two-part process. First, you have to determine what the possible x-intercepts are. All right? And you do this by something called the rational root theorem. And then, so after you figure out what the possible answers are, then you have to test them out. All right? You test them out by a process called synthetic division. Use synthetic division to see what your answers are. So these two important things I'm going to be teaching you here in this video. I'll say, okay, so let's go ahead and take a look at this polynomial that we have right here. We'll try to find its x-intercepts. Now, before synthetic division, the only way you could possibly do this was factor by grouping, which doesn't work in this case. All right, now, what we want to do is figure out what the factors of P are. Now, P is always the constant term. So the factors of P are 1 and 6, 2 and 3. Now, the tricky thing here is that's plus or minus all those numbers because -1 times -6 is also 6. Okay? Then we find the factors of Q. Q is always the coefficient in front of the term with the highest exponent. And what's our coefficient there? 1. So, in this case, plus or minus 1 are the factors of Q. Now, to find all the possible ones for the entire problem, you take the factors of Q, or factors of P, and divide it by the factors of Q. So, in this case, that would be plus or minus 1 over 1, 2 over 1, 3 over 1, and 6 over 1. And these are all the possibilities for this problem for its rational x-intercepts, which is pretty amazing. You think of all the numbers in the world that it could possibly be and reduce them down to these 8. Okay? So that is the rational root theorem. We'll practice this 3 other times in the video. Okay, now for the second part of this, testing them out with synthetic division. All right. Now what I'm going to do here is I'm going to draw a little box like this. Okay. And then I'm going to take all the coefficients of this problem, including the constant term, and write them down in a line. Okay. And then I'm going to skip a line and draw a line. Okay. Now, what I'm going to do here is a process called synthetic division. All right, now it's a guess. Okay, we're going to take the numbers that we just got here and choose off that list. Either plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. I'm going to choose -1. Okay, that's a random guess. All right, let me show you how synthetic division works. Bring down the first number, multiply these two numbers, put the answer here. Add these two, and do it all over again. Multiply these two, that's 3, put the answer here. Add these two. Okay. -1 times -2, that's 2. Add these two, 8. Doesn't work. Well, what number do you want at the end for it to work? You want this to be 0. And I had made a bad choice, so it didn't work. So it's going to give me another opportunity to try something else. Okay. All right. What else could we try off our list? Let's see, we tried -2. Or no, we tried -1. Let's just try 1. That's the easiest. I should have started with that one maybe. All right. I'm going to bring down the first number, 1. 1 times 1 is 1. Put the answer here. Add these two, -1. Do it all over again. 1 times -1, -1. Ooh, add these two, -6. 1 times -6 is -6. I got 0. Yes. All right. So one of my x-intercepts is 1. Now something I failed to mention here, how many x-intercepts are there in this problem? The highest exponent. So there should be 3 of them. All right. Oh man, does that mean I have to do this all over again until I find all 3? Guess them from the list? No, not necessarily, because these numbers right here mean something. All right. This means 1x squared minus 1x minus 6 equals 0. And we'll try and solve that. Okay, so we'll try factoring it. Hopefully factoring works. Oh, I think it does. -3 and +2. So 3 and -2 are my other x-intercepts. Hey, were those on the list? I think they were, right? Like a -3 right there. And -2 and 1. These are all on the list. All right, here's our second problem that we're going to try. This one's a little bit different. Okay. All right, first we got to find the possibilities for the x-intercepts. Remember, this is P. This one is Q. Now notice this time Q is not 1, it's 6, which means this problem's going to be a little bit tougher. All right, so the factors of P, plus or minus 1 and plus or minus 2. The factors of Q are plus or minus 1, 2, 3, and 6. All right. So what are our factors, or our possibilities, mind you? All right, I'm going to take this 1 and this 2, put them over 1. So that's 1 over 1, 2 over 1. Okay. And then I have to take both of these numbers and put them over 2. So that's 1 over 2 and 2 over 2, which is 1, which is already on our list. And then we got to keep going. I'm going to take this 1 and this 2 over 3, which would be 1 over 3, 2 over 3. Remember, it's plus or minus all these numbers. And then lastly, we're going to take both of these numbers over 6, which would be 1 over 6. Now 2 over 6 is the third, so that's already on our list. All right, so our possibilities are plus or minus all these numbers for our synthetic division. All right. Okay, so we'll go ahead and try that right now. All right, draw our little box. Take our coefficients and constant, write them down. Skip a line and draw a line. And let's take a guess. What do you guys think we should guess? Well, I don't really want to guess a fraction, even though sometimes we have to. So I'm going to try an integer first. Let's try the easiest number, 1. All right, bring down the 6. 1 times 6, add these. 1 times 5, add these. 0. Oh, but this is 0. 1 times 0 is 0 is 2. Nah, it didn't work. That happens. Let's try -1. See if that works. All right, bring down the 6, multiply, and add. Multiply. Oh, I think this is going to work. 2, -2, and 0. All right, so -1 worked. And let's take what's left over here. 6x squared minus 7x plus 2 equals 0. Try factoring. Hopefully factoring works. What do you use if it doesn't factor? That's right, the quadratic formula. All right, so let's go ahead and factor this. Let's see. I think it factors. Let's see. 3x, 2x. Let's try a -2 and a -1. All right, so if I put a -1 there and -2, does that work? No, that makes -8x. That doesn't work. All right, so we'll try the flip of those two. How about -2 right here, -1 here? Let's see, that makes -3x, -2. All right, -7x. So what's the x-intercept for this part? 2/3. What would make this 0? 1/2. So our x-intercepts for this problem would be -1 from the synthetic division, and then from the factoring, 2/3 and 1/2. All right, let's take a look at this problem. This one's different. How many x-intercepts are we going to have for this problem? Oh, there's our highest exponent. So we're going to have 4 x-intercepts. Now the way we start this is a rational root theorem again, p over q. So let's figure out our factors of p. Remember, p is the constant term. So that'd be plus or minus 1, 2, 4, 5, 10, and 20. Plus or minus all those. Now the factors of q, remember q is this right here, which is just 1 this time. Nice. That makes it a little bit easier. So it's all the factors of the p over plus or minus 1, which are just basically all the factors of p. All right, so those are our only rational possibilities for this one. So let's go ahead and do this. How's this going to work? An x to the 4th. All right, let's draw a box. 1, -3, -17, 39, and -20. Skip a line and draw a line. What do you guys want to try? You guys want to try the easiest one first? All right, let's try 1. Bring down the 1. Oh, 1 doesn't always work, but it did work that time. All right, now I got to find 4 of them. So now what do I do? All right, do I have to go back to the original problem and try another number? No. Okay, this problem represented the x to the fourth part. This part that's left over is an x to the third. So I'm going to work on this reduced equation by doing a box right here, skipping a line and drawing a line from that answer right there, since that's an x to the third. All right, so let's try another number. I don't know, let's try 4. So bring down the 1, that's 1, 4, 2, 8, negative 11, nope, that's not going to work. So I'm going to try something else. Let's try negative 4, see if that works. Oh, sweet. There we go. So now this part right here is an x squared. Let's see if we can solve that. So that's x squared minus 6x plus 5 equals 0. I think that definitely factors x minus 5 and x minus 1. Ooh, this is interesting. All right, so 5 and 1. So what are my x-intercepts? Here's what I want you to notice. We got an x-intercept of 1 the very first time, and then in the factoring, I also got 1 again. All right, so our x-intercept is 1, which happened twice, negative 4, and 5. Now I wonder, an x to the fourth, you know, if those are its x-intercepts, let's talk about its graph for a second. Let's see, x-intercept of 5 and 1 and negative 4. Now, if you recall, an x to the fourth, what does it look like at its ends? Doesn't it look like that? All right, so I'll start up here and come down to here. It happened a multiplicity of 1, so that crosses. And then here at 1, I think it touches because its multiplicity is 2. Touches, then crosses right there. There's a good sketch of its graph. For that very super complicated problem, now you guys know how to draw a more accurate graph of it. All right, let's do this final problem. Let's take a look at this. Oh, wow, it's another x to the fourth, right? So we know we're going to have 4 x-intercepts somehow. All right, let's get our possibilities one last time here. P over Q. So the factors of P, plus or minus 1, 2, 3, 4, 6, and 12. It's a bad 4, sorry. And Q, which would be plus or minus 1, 2, 4, and 8. All right. So let's go ahead and get our possibilities for the entire thing. Okay. So P over Q, possibilities. All of these over 1. So 1, 2, 3, 4, 6, and 12. And then 2 over, and then we'll do all these over 2. So 1 over 2. 2 over 2 is already on the list. 3 over 2 is not. 4 over 2, 6 over 2, and 12 over 2 are all on the list. All right, so let's go over 4. So 1 over 4, 2 over 4 is on the list, 3 over 4, and 4 over 4, 6 over 4, and 12 over 4 are all on the list. And let's finish this up with 8. So 1 over 8, 2 over 8 is a fourth that's on the list, 3 over 8, and then 4 over 8, 6 over 8, and 12 over 8 are all on the list. So those are all our possibilities. It's quite a few of them. All right. We better be good guessers. All right. So let's go ahead and do synthetic division. All right. What would be a good guess, do you think? All right. Let's try 2. All right, good guess that time. All right, so 2, which was originally on the list anyway, that worked. All right, now, so we've got it down to an x to the third right now. So let's go ahead and do synthetic division off of this. Okay, all right. Let's try -2. There we go. All right, so we got it down to an x squared right now. So 8x squared minus 10x plus 3 equals 0. Let's go ahead and try the factoring with this. 8x squared, that's probably a 4x and a 2x. Well, let's try -3 and -1. Does that work? Let's see, that'd be -12 minus 2. No, that's -14. Ooh, is this one where you have to use quadratic formula? Let's see. Try -3 and -1 here. Does that work? -6 and -4, -10. Yeah, that works. All right. So, what works from this set? 3/4 and 3/4. I think that was on the list. Yeah, there it is. Okay, and 1/2. And I do believe that was on the list as well. All right, and then the plus or minus 2 are the others. All right, so my x-intercepts are plus or minus 2, 3/4, and 1/2. 4 x-intercepts. Okay. Our homework tonight is Math Excel for School, x-intercepts, day 2. Be careful that some problems, all they do is ask for the possibilities, and that's all they ask, is ask for the possibilities. All right, so be careful not to do out the whole problem. Keep track of your work in a notebook as you do this, and thanks for listening, and I'll talk to you guys tomorrow.